Hi, I am Rajagopal, the principal investigator of Powernet here at Stanford University. Powernet is a system that enables aggregators, utilities, and other players in the electricity system to aggregate resources that are behind the meter in consumers and coordinate these resources at scale to achieve various goals for consumers and for the grid. The electricity grid is changing dramatically. A deep penetration of renewable is going to require a better coordination of resources behind the meter in order to meet the variability of renewables in a cost-effective manner. Coordinating these resources naturally goes through the cloud because they are today already connected to the cloud. What we are not able to do is utilize cloud in order to actually control and coordinate resources across the system. The challenges are both technological as well as finding ways that fit profitable business models and respect policies. What are the key technology concerns in trying to develop a system that can aggregate all these resources? First, we need to be able to coordinate these resources at scale. That means we need to aggregate millions of resources, coordinate them to achieve cost minimization goals, as well as goals such as offering ramping services or regulation services. These coordination needs to collect data effectively, but also preserve the privacy and safety of consumers. In addition to that, such systems will only be successful if you're able to make it attractive and easy for consumers to engage. You want the system to be able to learn consumer preferences and give appropriate incentives for consumers to participate in order for it to scale. So to address these challenges and understand these questions better, we are building a lab, the Powernet lab at Stanford. The lab actually consists of two actual homes inside a lab setting, which are connected to rooftop solar and to batteries or storage, as well as real water heaters and various appliances. These homes are connected to a grid emulator that emulates both the distribution and the transmission system. All of these homes are connected to our cloud solution, the Powernet cloud. And the Powernet cloud also connects to an industrial scale lab at SLAC, a national laboratory that's partnering us in this project. There we have larger loads, industrial loads, and the ability to test hardware in the loop. All of these systems can be controlled from operations center, and different technologies can easily be added or removed to homes and tested out in these conditions. This allows us to learn about what are the challenges when we need to coordinate using the cloud. What are the benefits? What are the electrical issues and physical issues and cyber issues? So in order to address that, using this space, we have first started tackling how to coordinate homes, residential consumers, and the resources behind the meter using cloud. Here is our Powernet project, and it has four basic areas which we're investigating. First, we have all the resources that are behind the meters: EV, batteries, solar panels, but we also have the different sub-circuits in our home. We are investigating a technology that we call a smart dimmer fuse to replace the fuse that you traditionally have in your home. The fuse today only responds to faults. The smart fuse can respond to signals and enable the control at every sub-circuit. This requires investigating power electronics. We are building a home hub that communicates digitally to all of these resources, and both can collect measurements and send control signals. It has a local intelligence that allows you to optimize the resources in a single home locally. The home hub is connected to a cloud solution, and we're calling it the cloud coordinator. The cloud coordinator has a visibility across the network and across consumers and can periodically synchronize and signal all the home hubs in order to share resources or achieve common goals such as services for the transmission network. In order to know what the capabilities a home hub has available, our system actually incorporates consumer feedback through different user interfaces. So we are investigating what are the most effective ways to learn consumer preferences. What are the right plans to offer consumers that will engage them? Finally, all of this system, when it's able to effectively aggregate consumer resources while respecting their quality of service constraints, we need to take this aggregate and participate in power markets. As part of this project, Slack is investigating how to set up the interface between the system and power markets, how to estimate the aggregate capabilities we may have. Using this system, we can test things like, can we automate the responses to prices of individual consumers while preserving their privacy and reliability? Can we coordinate across homes in a distribution network in order to shave peaks and provide grid services such as ramping or regulation? And can we use home hubs and the cloud coordinator to enable smart homes and buildings because we have visibility into the different behaviors and choices of our consumers? In more detail, what is inside Powernet? The first core piece is a set of algorithms for distributed intelligence and optimization. These algorithms operate under the assumption that you don't want to frequently execute instructions from the cloud every 5 minutes or something like that. So in fact, you want to run the cloud a few times a day and provide guidance for the home hubs who then do their own local decisions. And we are building algorithms that enable you to do exactly that. And the system can then operate in 2 time scales. Real time at the home hub level, which is every 5 minutes or below, and a slower time scale at the cloud level. Second, we are building the power electronics for this smart dimmer fuse. This fuse will have 3 capabilities. First, the ability to connect and disconnect every subcircuit on demand from a signal, an electronic signal. Second, the ability to modulate the power on every subcircuit. And third, the ability to collect high-resolution measurements from which the models that you need, the signal processing that you need in order to do this is very effective and efficient. Third, we are developing different types of predictive and diagnostic analytics. On the predictive side, we definitely have to do things like load forecasting at different resolutions, temporal resolutions. We have to learn the preferences of consumers from the data from the subcircuits. And on the diagnostic side, we're going to investigate can we learn inefficiencies and faults from the system, from data collected at every subcircuit. Finally, we are taking all of these components and testing it in a different real-world settings. First, we're going to test it in our Powernet lab and in the Slack systems. Then, we're actually going to deploy them in 20 homes in the Navy, partnering with the Navy. These different components require a very diverse team. In this distributed intelligence and optimization is led by Professor Abbas El-Gamal and myself. The smart dimmer fuse is led by Professor Juan Rivas. Diagnostic and analytics are performed both by us here at Stanford, as well as Sila Kilikote and her team at Slack. And the deployment is a joint effort of Stanford, Slack, and the Navy. We also acknowledge the support of Google, ARPA-e, and our various partners who are members of our advisory board, both academic and industrial. We look forward to seeing you in our website, powernet.stanford.edu. Thank you very much.